Welcome back, Algebra 2 students. Continuing our 4.4, this is 4.4b. Learning target for this lesson is I can add rational expressions. So we're going to look, before we actually look at a rational expression, let's just look at some simple fractions down here. So I have 1/6 plus 4/6. Now the thing about adding fractions, adding or subtracting, you have to have a common denominator. So the denominators have to be the same. And it is for this one, you both have a 6 here. So 1/6 plus 4/6, both 6's in the denominator. So that's good to go. When we do our answer, we just keep that same denominator on the bottom, and then we add the numerator. So 1 plus 4 is 5. So the answer is 5/6. But if you don't have a common denominator, like this one, I have a 2 and a 3. Those are not the same number. So I have to find that common denominator by using the LCM. So the LCM of 2 and 3 would be 6. So I'm going to use that 6 as my new common denominator. And then I have to find the numerator. So how do you get from 2 to 6? What did I multiply? Well, I multiplied by 3 there. 2 times 3 is 6. So whatever I do to the bottom, I have to do to the top. 1 times 3 is 3. Same thing here. 3 times 2 is 6. That's where the 6 came from. So multiply that to the top. 2. 1 times 2 is 2. Okay, just like in this one up here, you keep the same denominator and then you add the numerators. 3 plus 2 is 5. All right. So let's apply that same concept to rational expressions. So rational expression, they're written as fractions, and they have an expression in the numerator, expression in the denominator. So these are my two rational expressions. I'm going to add them. Now notice the denominators. The denominator for this first fraction is x plus 4. The denominator for the second fraction is also x plus 4. They are like denominators. So I can apply that same concept that I used up here when I had the same denominator and just carry that denominator over. So that's the step 1 in your success criteria. Carry over the denominator if they are the same. Carry over denominator if they are the same. And they were both x plus 4, so I carried it over. And now I just need to combine my like terms for the numerator. So I'm going to add the numerators by combining like terms. Okay, so x plus 5 is simply x plus 5. And now if you could, there is one more step. If you're able to factor and simplify, you would have to do that. For this one, you can't. It's already in its simplest form. But we'll just add that to our success criteria because that might come up later. Factor, simplify. All right. So let's look at another one. Go ahead and try this one on your own. All right, so step 1 is to look at the denominators. If they are the same, we can carry it over. And they are, they're both 2x plus 3. And now we just need to combine our like terms in the numerator. So I'm going to combine my x's. 10x minus 4x is 6x. And then combine my numbers here. Negative 5 plus 8 is 3. Now we can do that last step for this problem. The numerator can be factored. I can take out a 3. So I'm left with 2x plus 1 after I take out that 3. Carry down the denominator. And nothing can simplify, so this would be your answer. All right, let's try another one. Go ahead and try that one. All right. Checking the denominators, they're the same. So I will carry it over. And then I will combine my like terms. Like that. And then see if anything can be factored. This numerator can. I can pull out a 2 there. And that would be my answer. All right, so that is adding rational expressions with like denominators. Now let's look at some rational expressions with unlike denominators. So how do you solve this with unlike denominators? This is a little more complex than when you have like denominators. Our last success criteria for like denominators only had 3 steps. This one has 9. So you're going to have to really focus in and try to stay with me. But remember, if I'm going too fast, you can always pause the video, rewind it, and listen again. But your first step is to factor. So I'm going to factor the denominators only. All right, so factor the denominators. This is a difference of squares, right? And then I'm going to factor this one. Looking for the factors of 2 that add to negative 3. That would be negative 2 times negative 1. All right, my denominators are factored. Now I'm going to find the LCM of the denominators, and I'm going to use that LCM as my new common denominator. Because remember, you can only add or subtract fractions that have common denominators, like denominators. So I'm going to use the LCM as my new common denominator. But before I do that, I have to find it. Whoops, got ahead of myself there. So first we're going to find the LCM. Find the LCM of the denominators. All right, so let's do that. So x plus 1, x minus 1, x minus 2. That x minus 1 is a repeat, so we're not going to use that. Put it all together. The LCM is x plus 1, x minus 1, x minus 2. All right, I found my LCM. Now I'm going to use that LCM as our common denominator. So that becomes, this right here becomes our new denominator. So I'm going to rewrite the problem with the LCM as my new denominator. So I'm going to do x plus 3 over the LCM. Okay, then I'm going to do plus this fraction up here, 2 over denominator is the LCM. All right, now I can't just change my denominator without balancing out that fraction. So to balance out that fraction, what I need to do is step 4, multiply the numerator by what's missing from the original factored denominator. Okay, and I'll show you what that means. So, here is my new denominator. Now I need to compare it to the old denominator right here. What's missing from here to here? Okay, so they both have these x plus 1s. They both have these x minus 1s. What's missing here? What's missing is the x minus 2. That's what we added in to our LCM there. So to balance that out, I need to take this x minus 2 and also multiply it to the top. Let's do this one. So I'm comparing the old factor denominator, so the x minus 2 times x minus 1, to the new common denominator right here, all of this. What is missing from here to here? So I see this, they both have these x minus 2s, they both have an x minus 1. What's missing is this x plus 1, and that's what I need to multiply to the numerator. So that's the 4th step. Multiply the numerator by what's missing from the original denominator. All right. Now, step 5. We are going to either distribute or FOIL the numerators. Distribute or FOIL the numerators. Okay, so going back to the numerators, this one's going to be a FOIL. So I'm going to do x times x, x times negative 2, 3 times x, 3 times negative 2. All right, now I'm going to move on to my other numerator here. And this one's going to be distribute the 2. So it's going to be plus 2x and then plus 2. And that's going to all go over the LCM. We can combine them together now because they have the same denominator. So distribute or FOIL the numerators, and then we're going to put that all over the LCM for the denominator. All right, step 6. Now at this point, we want to combine our like terms on the numerator. Combine like terms for the numerator. So looking at the top, combine any like terms there. So got an x squared, Then I'm going to combine all these x terms. That would be, those actually cancel out, so it's just 3x. Negative 6 plus 2 is negative 4. And then all over that LCM, bring that down. All right, almost done. We're getting close. So close at this point. So step 7, you're gonna check the numerator and see if it can be factored. If it can, you need to factor it. Factor the numerator. So we've added the two fractions together at this point. Now we're just trying to simplify it if we can. So it can be factored. Be x and x, and then the factors of negative 4 that add to that positive 3. Negative 1 times positive 4. Bring down the LCM for the denominator. All right, so that's done. We factored the numerator. Now we need to give the domain. So again, the domain is any restrictions on x. The denominator cannot equal 0, so whatever x would be to give you a 0 denominator there, that's the restrictions on it. So that means x cannot be negative 1, positive 1, or positive 2. And then lastly, we're going to simplify if we can. So I can cross out these x minus 1s. Those can simplify. And so my final answer is, after all that work, x plus 4 over x plus 1 times x minus 2 for all x not equal to negative 1, 1, and 2. And that is the answer. All right. Keep that success criteria handy because you are going to try this one on your own. So keep that success criteria handy so you can refer to it as you work through the problem. Okay, go ahead and do that. All right, let's check your work. So step 1 is to factor the denominators. That's where you start, by factoring the denominators. Okay, after you do that, then you find the LCM from the denominators that you just factored. That's a repeat. Put it together. Okay, now we're going to use that LCM that we just found, and that becomes our new common denominator. So I'm going to rewrite this problem using my LCM as my common denominator. All right, now next step is to compare the factor denominator with the LCM, the new common denominator, and see what's missing. They both have the x plus 2, both have the x minus 2. It's missing the x minus 3. So that's what I multiply to the numerator. All right, both have the x minus 2, both have the x minus 3, missing the x plus 2. All right, now we're going to FOIL or distribute the numerator. I'm going to FOIL up here. Distribute here. All over the LCM. All right, now I can combine my like terms in the numerator. Still over that LCM. All right. Almost done. Now I need to simplify it. So I have to factor that numerator first. Okay, factor the numerator. Now, before I start simplifying, I want to make sure I take care of the domain. Now I can simplify. And I'm going to put it all together. So the answer is x plus 7 over x plus 2 times x minus 3 for all x not equal to negative 2, 2, and 3. Ta-da! Oh, there you go. Final answer. All right, let's try another one. It's going to be the last one. Okay, go ahead and try that one. Okay, step 1 is to factor the denominators. That cannot be factored any further, so I'm going to leave that alone. I can factor that. All right, just check this real quick. Middle terms would be negative 3. Outer terms would be 8. Negative 3 plus 8 is positive 5, and that's what I was trying to get at there. So that is good to go. Where's that? Okay, now my LCM. 3x plus 4. 2x minus 1, and then that's a repeat. All right, got my LCM. I'm going to use that LCM as my common denominator. Bring down that numerator from above. Put it over my new common denominator. Okay, now I'm going to compare the two denominators to see what's missing. Both have this 3x plus 4, missing the 2x minus 1. That is what I multiply here. Both have the 2x minus 1, both have the 3x plus 4. So we're good. I do not need to multiply the numerator by anything. It isn't missing anything. Okay, now I'm ready to either distribute or FOIL the numerators. This is going to be distributing. Bring all that down. All over the LCM. Okay, now I'm going to combine my like terms on the numerator. Just my x squareds And then combine my x terms, bring down that negative 12 all over my LCM. Okay, at this point I'm going to factor the numerator. However, the numerator is not factorable for this problem. So I cannot go any further, but I can state my domain. Remember, for these ones that are a little bit harder to just know the restriction by looking at it, you can always set that equal to 0 and solve for x. Just a two-step equation there. So x cannot be -4/3. You can do the same thing, same process for this one, and you get 1/2. And that is your final answer. So we have just learned how to add rational expressions. Stay tuned, the next lesson will be over subtracting rational expressions.